motor drivers, and those pretty much we're going to be using different ones. So we got it to the point now where I think 90% of the issues have been resolved with that. The other 10% will be resolved when we put the right motor drivers in there. There's something wrong either with the hardware of the motor drivers or with the firmware that's in there. One of the two things, because I could never get anything consistent out of it. First one goes into air mode, then goes into the other air mode. Right now, to give you an idea, those of you that were in on that, we were able to get 70 RPM running on all four motors and drawing only 14 amps when we were running it yesterday. And those of you that were in there that were trying it before, we were getting about less than half of that. So we're now in there, and Peter Solomon was trying to put his hand on the wheel, he couldn't, because it was drawing so much torque that's on there. So we're on our way. I think that part, design will be behind us. But what we're going to be doing today, right after the meeting, we're going to go out to the sand pit. It's a good area out there. The sand may be a little bit wet, but what we're going to be doing is we're going to run that robot around. We're going to do some testing and get it up and running. So that's kind of what we're going to do right away. I talked to security. We have clearance to get in there. What we're going to do is take the robot down there, and they'll open up the gate for us to get in. Now, the only thing we got to do is we got to leave it as we found it. So no sand all over the place, no big holes and things like that. That's what we have to do. So that's the thing that we're going to be doing right after the meeting. And also, the mechanical team, what they're going to do is we're going to take a look at some design issues that we have. I've charted you guys at the beginning to more or less take a look at the design, our design objectives and see what we needed to do. So we're going to talk about that today. That's on there. Other thing is that we do have, we'll talk about the outreach. Lynette and company have got some things regarding outreach. We also have some other things as well too. So pretty much what we're going to be doing today is we're going to get some meat and potatoes. The other thing I want to make sure that everybody does, we're approaching a part of the project where we're going to have to be heavily focused on what we're doing on our areas. We have some people here that are taking 2 and 3 teams that they're focused on. Well, I got news for you. Some even 3. You're not going to be able to focus on 3 areas. And you're going to have some problems depending on your choice focusing on 2. So what I'm going to be asking everybody, and I'll be writing a letter because I think not all members are going to be here today, is they're going to have to take a choice of the maximum of 2. And if they're having trouble supporting 2 committees and participating in 2, they're going to have to make the choice of 1. Just showing up and just saying you're there is not enough. You actually have to be doing it and actually have to be supporting the team as well too. And that's very important. That's not an option. This is going to be mandatory. If you can't make up your mind, I will certainly help you make up your mind for you. That's on there. But I want to make sure that if you're saying that you're on the mechanical team or if you're on the electrical team, that you are playing an active part, not jumping back and forth between them. That's not going to happen with this one. It's not going to happen that we have in there. So that's going to be there. So unless you're prepared or you have the time on your schedule to do it, then we're going to do that. I don't want people just hanging around. I want people that are actually going to be doing, and team members that are actually going to be doing work and supporting their teams. Because right now what we're doing is now we're coming to the serious phase of the project where we're going to be doing some things that are going to happen. We have some preliminary testing that's been completed. We're going to be looking at some design issues that we have to address on the robot and seeing what we're going to be doing. That's going to take time. And let me explain to all of you in very stark terms what we have. It is the beginning of October 7th to be exact. We have exactly about 2 months until the end of the semester. That includes Thanksgiving Day holidays, Veterans Day, and other holidays that we have. So you don't have a lot of time. Ordering parts through the purchasing department takes about 3 weeks. That's if the stuff is in stock, because we have to go through approval. I will not bypass the purchasing department. So nobody even tell me, well, can we order something and expense that? That's out. The only time I'm going to do that is after April the 15th, when it's near the time to do that. So don't even talk to me about it. Don't even tell me, well, I can go buy the part from Ace Hardware, I'll just give you the slip. That's out. Everything has got to go through purchasing, so we gotta put that into account. We did that last year, and it was an accounting headache for myself, Gloria, and the accounting department to put all the books together. It's not gonna happen again. End of discussion. Other thing that has to do with money is that the foundation awarded us $20,000 this year for the robot. Out of that, $8,000 I've allocated for travel and expenses. That means for all of us to take 2 vans at least and head down to Florida. And that covers basic meals, $30 a day for meals. That also covers the hotel. We're figuring roughly about $650 a student to cover that cost. That's about what it costs to do that. So all that comes out of that $20,000. We have already committed almost $2,000 out of the remaining budget, which is for that. So roughly we have $10,000 that we have left in the project for this. And by the way, there are no other sources of income. As far as I'm concerned, somebody's saying that, yeah, I have a friend that'll contribute $1,000 to the project. As far as I'm concerned, until I see it, it's not real. You know, there's something known as, I'm from Missouri, the show me state, and that's exactly what it is. Show me the money, okay? Other than that, that's what we have right now. So there's time issues. We have to have the material ordered if we're going to be within running by the time the semester ends. That gives the purchasing department time to get the approvals, contact the vendors, and getting them in. Some vendors, what they do is they shut down or they have curtailed hours during the Christmas holiday. So we're going to have to get our orders during that time because a lot of people take vacations between Christmas and New Year's. What that means is that I want to be able to have materials ordered and be ready for us by late January, early February, so we can start with the fabrication. Now, being since this is a redesign, that shouldn't be an issue, but it may be, depending on the amount of redesign that we have. Some parts may have a long lead time. The other thing I want to make perfectly clear to everybody is that we have other teams whose work we're dependent upon. So not only do we have to fabricate the robot, but the electrical team has got to wire it, and the software team has got to be able to run some trials on the robot and optimize their software and see what works and what doesn't work. There's only so much that you can do in software on a computer or on a laptop. You have to have the live robot to do it. Last year, we had exactly 0 time. We threw away 6 months' worth of work. In essence, we've wasted that time because we were not very big. And I'm not going to have that happen again. You can rest assured of that. We will be doing that. That's in there. So scheduling to me is extremely important. It's in there. Those of you that were on the team last year, I don't think you want to have the prospect of, again, trying to get the robot to run at NASA on a 10 by 10 foot pit. I'm surprised everybody didn't kill each other because of the tension and everything else. So I want to make sure that we have that. That has to be met. Last year was the first time that we went down there in 2017 with a non-functional robot. I said to myself, we're not going to get this thing running. And that is, and again, against all odds, we did. We did get it running. Not very well, but at least we got it running, which is an accomplishment in itself. So I want to make sure that we have that. So my objectives are 3: cost, my objectives are scheduling, and the other objective is that what we told the school. You know, there's somebody providing money to it. This money doesn't come from just everybody. It comes from the foundation. And what I told the foundation last year, when we prepared the proposal for this year, because I have to do it a year ahead of time. So this year I have to worry about what I'm gonna do in 2019. I went up there and I told them, I says, this year, when we went down in 2017, and I gave the proposal in April, I told Oakland's Foundation that we expect that we're going to take a hit this year in terms of our standing because the robot that we have was a new design. So everybody pretty much accepted that. Pretty much everybody accepted it. That, hey, we took a hit, we had a large number of inexperienced team and everything else. So the people that back us, the people that had the money for us, said, hey, that's great. What I also told them is that this year, we were going to go in with, we were going to take the lessons that we learned, we're going to modify the robot, and what we're going to be doing is, we're going to, with the expectation of an improved design and going in there. That's what I told them. And that's what they expect out of us. Not only the foundation, but also the people that I report to. So they expect pretty much that we're going to take the design that we have and we're going to put some improvements on it and get it to run. Now, that is pretty much what we're looking at. So the thing is, that's the expectations that they have, the expectations that we have as well here. So we're going to have in there. So again, we don't have a lot of time. Money can, $10,000, you think that's a lot, that can fly away pretty fast. That's on there. And again, that's based on an initial thing, based on last year's funding. So, we were into something I expected that we had to go in there. So I want to make sure that everybody understands what the objectives are and that what was in there. Because this is a critical time. Now what happens is we're going to have to start really digging and crawling and doing everything else. On top of that, some of us are going to be working with outreach. Because we have to be able to do outreach events for everybody here. Lynette's going to talk to us more about that. So some of you may be, and I require everybody on the team to participate in at least one outreach event that's on there. At least one or two of them that's on there. Because that just is important. We're not going to throw away 30 points for that. So this is not just a robotics project. So we have some real constraints that we have to deal with. All of you are students in the school or have got work or both. All of you have other constraints that's on there. I can see that. I see that from all of you. And that. So keep that in mind, because when we're doing scheduling in industry, what we take a look at, not just the time, but we take a look at the availability of people to do the job. How many hours in a week do we have to account for resources to do something? Take a look at your own scheduling. How many hours do you think you have per week to work on this project? Because that plays a big part in that, okay? That plays a very big part in what you're doing. So we need to do that. That's why what I'm trying to do is that we have to work smarter, not harder. Not like last year, when what we did was we took we did 90% of our work within the last 3 weeks. That was totally insane. And that's not going to happen again. That's on there. So and I'd be surprised the way we trashed up this room. I'm surprised I didn't get in trouble for that. By the way, nobody said anything. And again, here's the thing to look at. I went this year and I pushed to the school going to Pumping Station 1. Let's understand what Pumping Station 1 is and what role does it play in us. Pumping Station 1 allows us to have a makerspace. It allows us to have an ability and a place to do fabrication rather than trashing up this room like we did last year. We can go down there, take our parts and put it in. In addition, Pumping Station 1 also gives us some other people that can give us advice. They aren't going to be consultants. They aren't going to help you build the project. Those are two different things, and I want everybody to understand that. Because once they do that, they're going to say, hey, you got to pay us for it. So it's a knowledge base that we can draw off of, that we have. But that's what it is. It helps us more than anything else. It helps us be there. And that's what the role of Pumping Station 1 is in our project. It is a place for us to go there. It gives us access to machines that we don't have here at Oakton or we have limited access to. Simon can tell you all about the time that we couldn't work on anything because they had classes downstairs. That's what we're trying to do. We're trying to take that out of the way. Pumping station isn't going to help us build a robot. They're not. If anybody here has any illusions of that, you can just put them to rest. That's not what the intent is. That's on there. The intent here is that we apply our own resources to do it. And then I want to make that very clear to us because I think some people here may have the idea that, gee, we got a lot of things in there. Well, look, they give us facilities. They may give us some advice, say, hey, do this or do that. But don't expect them to sit there and spend 25 hours grinding something out for you. They ain't going to do it. That's not going to happen. That's on there. And that's what we want the role of pumping station one to be, as a makerspace. It's a place where you go in, you might get a little bit of advice that's on there, a machine to work in or parts. That way we're not trashed. That way Simon doesn't have to bring his saw in here and saw away at everything that's in there. So again, that's kind of what we want to do. If any of you have seen any of the pictures of this room last year, you'd be horrified. You'd be absolutely horrified. And that's what we're trying to do. I want to make sure everybody understands that. We are in a challenging situation. We are going to be challenged. And as I said before, what we're going to do is we're going to try to make everything within schedule, within budget. And that's what the intent is here is right now. Because what I want us to do is I want us to go out there and feel like we've been a success, not feel like that we could have done better. And that's one of the things that some people came away with last year. Gods, we've done so well, but gee, we could have done better. That's on there. And I know from Lynette, from Jeremy, Simon, everybody else that was there, Sanjita, everybody else, that was the feeling. I think everybody came away that hey, we could have been up there. And you know what? If you look at the awards night, we weren't that far away from getting awards in 2 categories. We were 6th in system engineering, 4th in outreach. That tells you a lot. That tells you quite a bit. And had we done better in robotics, which we earned 0 points, we could have pushed ourselves even further. So again, this is kind of what we're looking at. And so anyway, pretty much what we have here is, let's go on with this. Yeah, yes, sir.
I just have a question about the budget. So do we have some kind of transparency on the budget instead of in terms of checking how much we've spent and how much?
What I'm going to do is I'm going to be giving Jeremy. He's been doing that for the systems engineering report. I'm going to be giving him some kind of idea what some of the expenses are.
Okay.
That's on there. I'll be getting some of those figures from Ahmed because of the stuff that we've ordered. Right now, it's about $2,000 that we spent, chiefly on the motherboard and everything else that we've gone in there. Again, $10,000 doesn't go very far.
Yeah, I'm asking just because when we were choosing the ATX versus ITX board, budget was a big point, kind of.
Mm-hmm.
Probably took at least 40 minutes to decide.
Yeah.
100, what was it, $80 difference.
Yeah.
And so having a bit of transparency would help, probably.
Definitely. We will do that. I will get some of those numbers and put them together. But right now, from what I can see, that's kind of where we're standing at right now as far as, and that's going to become, by the way, Alex, that's going to become even more important as we start spending money.
Exactly.
As we start putting money. Last year it was pretty much, we stayed with, believe it or not, as screwed up as everything was, we stayed within budget.
Yeah.
As absolutely screwed up as it was, we actually stayed within budget. Yeah, no, that's what you call luck. That's what you call luck, is what you call it. So, we did that, but I think the issue was between everything else that was going on, and we didn't have to do any funny transfers in and out of anything. Because right now, to be honest with you, I was told by the dean, Division II dean, not to expect any kind of contributions from any department's budget this year. That's it. He says, you got 20,000, that's it. He says, unless we get alternative funding, which there's nothing on the horizon right now, then we don't have that. So I want to make sure for all of you that all of you understand what we have here that's on there. So what I'm going to do right now is, mechanical team, what you guys are pretty much up. You want to do your presentation, show us what we got. We're going to make a decision today. And that's it, we're not gonna wait. October the 7th, you guys have, where do you guys have your presentation at? PowerPoint? Okay, so yeah, you guys can log in, it's on there. Yeah, let me put this on. Okay.
Sean told the camera doing this, so.
Okay.
I'll put this. Oh, there you go.
Okay. Yeah, you wanna bring it in?
Yes.
Okay, go ahead, yeah, go ahead, bring it in. 2000, yeah, it's in the other, yeah, we put it in the other room. All right, let me take this, I'm gonna get out of your way. Sit down here. Okay.
Someone want to turn down the lights?
Yeah, we'll turn down, yeah, I'll turn it, yeah, go ahead. Okay, thank you, Sangeeta.
Thanks, Sanjita.
All right. Okay,
Yeah.
all right, sounds good. You guys got it? Okay, good, good. All right, Luke, thanks for doing it. Okay. Go to the, yeah, that's
I've been
cool.
I did look at these. It's like perfect.
Sounds good.
I would recommend looking.
Sounds good, sounds good. All right. Ready? All right. All right.
Start it out. You go straight to the first one. Alright, so we actually have been working on just starting from scratch redesigning. Why? Because we got a new set of rules this year, as everyone aware. I know Andrew was talking about, we talked that all we need to do is just incremental changes in the past year's robot. But then NASA threw us a curveball, and initially we thought that it tailored to our strengths, which it did. But as the systems engineering that we need to look at the project right from the beginning, looking at the goals, objectives, and we need to evaluate the past year's robot, see if it's still, aligning with with new goals, and then go from there. Yeah. So we started out with our product design specifications. What do we need to what do we need readjusts?
So these are the design specifications that we need for this year. So we need to collect IC regolith. We need to avoid the bigger parts so we can maneuver it better. We need to that's to the material properties and all that. And then material it's the same as last year, and then size it's the same as last year, and serviceability we need to improve that. So our robot right now it's not able to do that. So if we're gonna have to
Explain why.
So if we're gonna have to change to that, because robot is not able to input IC regolith, it's not great in maneuverability.
Prove it.
We're
Okay.
gonna get into it with the design. So
We're gonna
this
get
is
into
just
it.
show
Okay, very
this
good.
goes on to show that what we're trying to achieve, all the criteria that we're trying to meet,
Okay,
and test conditions how we're gonna meet them. So, stuff like the dig-ins and go come from the design itself, and we will have to test it out, whether from a bench test, from prototyping, or from full-size testing. So these are the criteria we need to meet according to the new rules, and let's analyze each one of the designs. So for the first one, obviously the last year model, which has plenty of strengths, which actually help us out with the new rules as well. The big scoop in the front, we're able to scoop up all the IC regolith, doesn't matter what the size of it is. That's some other concepts that we come up with. We'll struggle with it. We're able to dig deep, although we don't know just how deep. From last year, we were able to just scrape off the surface. So, we believe that it can, but it hasn't been proven yet. It's something that we would need to test out before proceeding. It also has large carrying capacity, which is which is, it was tailoring to 2016 rules more so than 2016, 2017 rules more so than next year's rules, this year's rules. Since before, we got points from regolith and the gravel. Now the regolith doesn't matter, so we don't need as large carrying capacity. So the big reason we made this was to increase the carrying capacity. Now it's decreasing against this year, so it's it is a pro, but for our case with the new rules, it doesn't apply as much as it did last year. And there's definitely some flaws that we had there. The center of gravity of the mechanism is way in front of the axis of rotation, so not a great mechanical advantage, and we've seen problems because of it with the reinforcement, with the drive, and it's also not the best digging sequence because you have sequential moves that you need to go through, and the downward motion is limited based on the initial setup of the linkages. Once we get the linkages dimensions, we can't adjust it after the fact. There's some adjustments that we discussed about making it obviously shortening the chassis, getting rid of the front box over here. We have to shorten the chassis, get rid of this. And if we perforate the hopper, we're able to do the sifting as we're digging it up. We're digging up the regolith with the icy stuff. And we're able to sift it right in there. It does, we are lifting it from the ground, so we're taking time to process it. It's multi-stage process, but we are able to do that. We also need to get these two motors out of the way because that was a big hurdle in the ground clearance. We smacked into a rock with them last year numerous times. But yeah, there's a bunch of little improvements, but because of these improvements, all those little increments add up. There will need to be a ground up rebuild. New chassis. We'll have to find new mounting points for the motors. Redesign the wheels most likely because they were heavy. I know we can do better, and if we make them larger, it'll be easier to turn. And because of different chassis, different pickup points possibly, and this design was made to go 9 to 11 inches deep, which is just scraping the icy regolith layer. So once again, we need a lot of time to redesign the lengths and make sure it works with the rest of the chassis. So that's just some of the problems. I mean, there's still a lot of potentials, but we wanted to analyze every option that we had. So next alternative is one of the fresh concept that we came up with, which actually isn't fresh to begin with. We had this last year as well. Completely different set of group people came up with it last year. It was one of our concepts, and this year, without really even us and my input, without Peter's input, these guys here. One day I came in late and I saw that they came up with this on the board, and that's because this design we believe has a lot of merit, and you guys can talk about why we believe so.
Alright, so basically this is the bucket wheel excavator. What it's gonna do is it's gonna spin this big wheel in the center of the robot, and it's gonna lower it down using kind of like a gantry system. The scoops will scoop all the way down to the icy gravel, and then what it's gonna do is it's gonna actually sift out the regolith within the actual bucket wheel. It's gonna have these perforations with a cone on the side. And then what's going to happen is there's going to be a conveyor belt system, which is actually on the next few slides, I think. Can you just like show them the wheels? Yeah, there. Yep, that's kind of there. Yeah, so right there. So what it's going to do is it's the icy gravel basically, or the regolith will get sifted out with the cone, and the icy gravel will fall into the conveyor belt system. Be lifted up into the hopper, and then from the hopper we could throw it into collection bin. I know it sounds a little complicated, but there's this big machine. I can't remember what it was called, but usually they use it for coal mining, and that's kind of what we were basing it on. What the machine would do is basically just cut right through basically a mountain, and basically use conveyor belt system to get it from the wheel to the processing plant. So this is what we kind of came up with.
This is a proven design in the field that's already used in the mining industry, and it combines a lot of the functions into a single step. digging, sifting, and collecting is all in one motion. There's no intermittent steps in between, which increase the efficiency of it, we believe. And this will help us to get down to the icy regolith much quicker, and
Yeah,
concurrently sift out the stuff that we don't need anymore.
and you don't have to stop until the popper's full, you just can keep going until it's full, just dump it out, come back, and just dump it in again.
Yeah, we're gonna basically have a full hopper's worth of icy gravel when we get back. And also a great thing about this design is that the wheel can be basically 0.75 inches, maybe a little bit shorter for clearance, and we could easily get down to the icy gravel. We'll have like I don't know 5 or 6 centimeters to work with of icy gravel, and that's more than enough to scoop it all in, and then basically have a whole entire hopper through when we come back.
So this is, I think this is the second idea we came up with during our kind of design and idea phase. The idea behind this, it's kind of a boring machine. The big benefit of it is super efficient. So it'll go down, and because of the shape of the cone, it'll very easily penetrate through the regolith and icy regolith. Can be very compact, so it's relatively rigid, but it also has a lot of downsides. It's kind of speed us into playing different ideas. It's intermittent. So similar like this current design, it's intermittent. So we'll dig in one spot, we'll collect as much as we can there, but to collect more, we have to move the robot, re-dig, and it's time consuming. And the two other big cons of it are that it clogs up, which is generally kind of the auger problem with the auger. And then therefore tight polish is needed. And then as we consulted with Luke a little bit, we kind of came to the conclusion that it'd be super difficult to
Gauge whether, when we run into problems, so we have to gauge the
Yeah.
software.
and automate. There we go. That's what I'm looking for.
And this is just kind of like off the wall idea, but sometimes those will be alone.
And we built off all of these ideas to some extent.
This was one of ours, so we came up with like a DAT type system, so we just go into the dirt, separate out all the fine regolith, and then go get to the payload quickly. But that took a lot of moving parts, and it will be really hard to automate, so we kind of got rid of that idea.
And I'll talk about the decision matrix that we came up with. Here you can see at the top the 4 designs that we evaluated with the metrics that we went by. Some of them were used from last year. Cost definitely is a big factor, but since we had more than enough money, I believe, as I'll show later, we didn't put a lot of weight to it. The 2 big things that we need to emphasize is digging effectiveness and reliability. Because if we are not able to stay reliable for the 10-minute runs and dig effectively, this is no go. We're just not meeting our goals. Secondary, we need to, once we do have a reliable working robot, autonomy comes in. And we can pursue that extra 500 points that we get. And serviceability, because last year's robot was a peach working, trying to replace some of the parts. We didn't put a lot of consideration into how we would service the parts. Taking out the rear motors, for example, required taking out the actuators, the top covers, side covers, and wedging your hand into a tiny spot in order to take out 2 screws. So first and foremost, we need to make sure we stay reliable and we're digging effectively. Then comes the autonomy. That's a good base for autonomous use. And at the end of the day, we have the cost, which whether we're rebuilding the old design or starting from scratch, it's more than we had last year and a lot more than we anticipate to use. So for the cost, the excavator, obviously we're going to reuse a lot of parts. It scores highly in here. The other design's a lot lower. With autonomy, I consulted Luke and he gave us evaluation on how he feels each robot will work. The ground splitter is awful, obviously. Vertical tunnel boring machine, we're not able to gauge the effectiveness of the digging. We can't tell if it very easily if it gets stuck. So it's middle of the pack. Do you want to go through this, Luke, or do you?
I don't mind.
Excavator, that was good, but it's like a lot of a lot of sequential moves, and like I said, we don't have a good gauge of how deep we are. We can get it from potentiometers. It's not very precise. You know, it's still good base. We can work with it. It scores pretty highly, but per looks evaluation, you know, we're able to with the pocket wheel, we're able to go down um, using lead screws and have potentiometers on those very effectively tell us how deep we are. And you know, once we're in deep, we can just move forward, single motion to continue the digging operations. Uh, Serviceability, we think, you know, the excavator was kind of poor. Bucket wheel, we're not sure. We scored a little lower. The boring machine, since it's you know simple motions, you have one rotating parts that goes up and down. It should be easy to service. You know, it's the drill will have lower profile, so it's smaller parts, and they should be able to. We shouldn't have a problem fitting it there. Uh, and then digging effectiveness, like I said, excavator. We saw it scraping the surface. We don't know how well it's gonna do gravel deep down there. Looks telling us that we might need a second arm, another another
Joint.
another joint, which would increase, which would make it more complex. And from my point of view, it's not easily implemented. Bucket wheel, you know, we've seen some previous designs from last year's from other teams implement a successful bucket wheel that goes down very quickly and efficiently. So you know, based on our scores, you know, the two worst designs were, you know, we kind of pushed them aside the vertical tunnel boring machine, and ground splitters we kind of pushed them off the side right away, and the scores reflect that, and the bucket wheel came on top. So we decided to pursue it a little bit more. We're coming up with a manufacturing plan. We're ready to start 3D printing the wheel, the big bucket wheel, so we can analyze it in more detail. And we would like to go start testing it, see how much torque we need to start turning it, so we can pair it up with motors, right size motors and gearing. You know, we're ready to start printing them this week, and we would like to schedule either a trip to IC to dig in the actual regolith, or we can even just go out here to Sandlot and start checking out the performance and evaluating it. Um,
And conveyor belt, we're looking into online sources. We're planning on contacting a few this week or next week to get exact prices and dimensions figured out. The payload and loading mechanism, the one we are currently in design, is relatively similar to the 2017 design. So it'll be actuators into a relatively square triangular hopper that will just get unloaded. So there's not too much engineering left.
And the cost would be a lot fewer because we're gonna scanning some parts from the previous one, and we're gonna have enough budget to purchase the new parts that we need.
Then we had established some milestones the upcoming release.
so getting into the budget, we'll start to gauge it because it is a new design, but we're able to estimate a lot of things based on previous year's design or some of the parts we actually looked online and looked at the prices on there. Yeah, the big changes would be the bucket wheel itself, the excavator portion here. You know, we got budgeted for sheet metal and motors. You know, we double them up, make sure you get extra just in case they fail with the motors, gearboxes. We got a couple of lead screws on each side, raising and lowering it with the followers as well. So this is all priced out. You know, a lot of this was paid from last year. Last year we spent almost $400 in hardware, nuts and bolts, which was kind of insane. I don't think we need to spend that much this year, but just in case I budgeted $300 there. Miscellaneous sheet metal and tubing, I budgeted tubing down here, but you know I'm giving an extra $1,000. You know, last year our order from Online Metals was $1,400, so I'm just giving us a little leeway, as well as specialty tooling that we might need that we haven't considered yet. But just putting in budget, you know, miscellaneous stuff like water jetting fee for wheel faces like we did last year was very successful. You know, it was quicker and more precise than machining, so definitely gonna go with this year. So after considering a lot of the specialty parts and budgeting some of the metal parts, came around 6,300, which is still well below budget, but we know there's gonna be stuff that we haven't considered yet. And I think this gives us enough headroom to work with and, anticipate any surprises, and we do have enough in the budget to consider that. And Drew, do you have questions about this? No?
Any
Do you have
questions
questions about this?
Well, for one thing is, I would add to that budget about 10% to account for inflation or anything else. I have my doubts. I'm looking at those figures and I have my doubts whether we're getting everything else. To be honest with you guys, I'm gonna tell you right now, you're asking us as a team to give up a design that we've actually fielded for something that's unproven.
Well, we fielded it, but there was a lot of problems with it.
I understand
It wasn't fully operational.
And I understand there were a lot of problems with it, but that was mostly due to poor scheduling that we had in there. What you haven't fully told me is that what would be the difference if we put up some time into that robot versus what we're doing with the new design, what that's going to be. Right now, what we're doing is, listen to what I'm saying. Right now, what we're doing is you're comparing it against this as is. And I agree with you 100%. As is, this robot is a piece of junk. I'll agree with you. The original intent of what we did this year was to see what we can do to improve this robot. It's on there. We agreed that this design has some faults, it had some things, but I'm not convinced yet, and you haven't convinced me yet, that I'm going to give up 1 year of error, trial, error, as well as experience to go with something completely brand new. Most teams that have done this type of bucket, it's been like a 2-year project. I can tell you that right now. They come in the first year, all their assumptions are gone, and they come back the second year. So the successful ones, you go in there, if you go back to 2015, they've been there before and they've worked on that. You're not talking about something that's trivial, you're talking about something that's fairly complicated on something like this that's on there. So we're gonna go in, $6,300, I would say you're gonna run pretty close to the limit. And that's not including, what we haven't thrown in there is the electrical costs. The electrical costs as well too.
Yeah.
We're gonna hit close to 10,000. And that's being optimistic. It's on there. As far as time goes, I'm skeptical. I'm very, very skeptical that we can pull this off as a team in time for us to do it. Because to be honest with you, the electrical needs time to put the wires together. We've all seen what happens when you try to do things in a matter of a couple of days or even a couple of hours. It's a disaster. We've all seen what happens when you throw away all of the work that we've done on autonomy and just go bare bones. We need to have that time. So I'm not talking about being ready in May. I'm talking about being ready in March. I'm talking about going in. Okay, whatever.
You can still go.
You can still go, but I'm talking also about is being there in March. How about being before the spring break, that we have something ready so we can test it out and put it together.
That is the plan. We're
That's the plan.
trying to finish it by the beginning of May, March. We already have plans and motions for prototyping. Do you
So I
want
think
to?
I actually answer some of the concerns here, since I'm the one consulting in regards to this design. Okay. Here's the couple things. First of all, the platform of this robot and the total cycle time that it's going to take to move the amount of soil, the profile, and the build, is going to actually be wasted. We're not going to have them be able to be effective in 10 minutes. Okay. Secondly, in regards to this chassis, there's a reason that I've been evaluating this design, why the pivot points have been set where they are, and based on that drive system. If you reduce the total length of this, you will lose the advantage of a stable base, okay, and you're going to be reaching out far. Just like an excavator has a very small profile, okay, it has a very, very large base, so they can do it. But excavators also take time to get to certain depths. Because of this wheel mechanism, we're all able to sit there and make use of every motion and every rotation as it excavates and sorts. Now, the question is, and I did come up with a solution about how we're going to build this. You ever seen rock tumblers?
Yeah.
We could buy the whole head unit. The whole head unit is pre-manufactured.
How much?
We'll figure it out. It should be no more than $300. I've found them both for polishing in the polishing industry or whether you prefer equipment, etc. And we already came up with an idea how to make the scoops on it. I'll show you how to drag all that. A lot of the stuff that we considered for this design is going to be done by hand. It's not. It can't be. We don't have all the tooling, and God knows I've already worked with that curve, what do you call it, that restriction. So I've already have a process and plan for that. We didn't get time to discuss it, but the one thing I've been urging this mechanical team to do is to build a 3D printed version of this, and we will do cycle tests so that you can, and everybody can see, including software, what's going to be required to develop the automation. This design is still, these two hinge points are ridiculous. There's an actual design from Caterpillar that you could have completely copied and utilized. But that required a lot more money, a lot more parts, a lot more, basically feedback to our software team in regards to the position. This has only 3 strokes. That's it. Down, a rotation, and a total that is going to be loaded.
So I should add something. If you do add the extra hinge points into the excavation mechanism, the score for autonomy on the robot will decrease. So it'll be much harder for us. Like I scored,
But are we optimizing for autonomy? Because it seems like they're optimizing for how much ice and regular we
Well,
get.
we
So
are
I'm kind of
optimizing.
confused, what are we
It's
out?
both.
It's both, you can't, you have to.
Yeah, you have to work for one. You're not gonna sit there and optimize for both.
well, I'm not saying optimize for, I'm saying with whatever they come up with, the ability of us to make that autonomous decreases with the complexity of the mechanism. And so when you add the extra joint, it becomes harder for us to bootstrap
Yeah,
autonomy.
because you have to be, and I agree, you have to be able to position that, you have to be able to know that. In other words, the robot's gotta know some way where that mechanism is at, either a relative or something that it's in there. My question is to Luke. You've worked on you have 6 months worth of work. How much of that are you gonna throw away going with this design?
So going with this design, we can keep all the work that was related to moving forward and backward, as the drive mechanism will remain the same. And the hopper will be the same relatively as well, as it's just move the excavator all the way to the top and then move it all the way to the bottom.
If both of them.
Yeah, and so the only thing that would be significantly altered is the autonomous digging code, which is relatively minor in the grand scheme of things. And so not too much is wasted. There's going to be some refiguring
You are gonna have to do
for how to sense it and like the strategies for digging, but it's not that everything is going to waste. There's a lot that we can reuse, and we can even reuse some of the code for autonomous digging because the arm was driven by a motor, and so as long as we the gantry system will be motor powered, so we can use the same kind of lower into position code that we already have implemented. So that's not removed either. It's just an altering of what we have to accommodate the new.
What I like about this, since you're bringing that up, is you're not gonna be having a shift in the center of gravity because of total payload.
Yes.
Because of how we built it with that C-frame, okay, I'm sorry, the U-frame. The U-frame will allow us to stay in center of gravity. All you have to worry about is the depth and then coming back up. And then exit or then what we call dumping, and that's it. So when we came up with this idea, we went full circle. We even gave this excavator an opportunity to took ideas from that. And it ended up drawing us full circle to this wheel bucket concept just because we've seen a team do such a good job with it. Now, why they put it in a tricycle position, I don't know. It gave them the lack of stability in the profile. We're not making that mistake. As a matter of fact, the reason why we went with this design is because we stole ideas from it. We learned from their shortcomings and the lack of, I guess,
Oh, you're
engineering.
talking about the team that was
North Dakota.
Yeah.
North Dakota, okay.
And they did a phenomenal job. The only problem is somebody didn't go in there and give them the idea of keeping that center of gravity and using it for their advantage. Why they went in this triangular, extended out format is really, I think, a lack of experience. That's all it is. But I'm very confident in has designed. I think it's gonna do terrific, and unlike last year, there's follow-through. There's actual follow-through. I've already found solutions, and I know that we do not have skilled welders. I know that we do not have skilled machinists. And a lot of this is gonna be handwork. And each and every one, that's why I like,
My big, yeah,
Matt's got a lot of, handcrafting skills. He's a craftsman of sorts, and I terrifically, saw his work. He's gonna be very key to this. And then the experience that Simon brings to the table from everything we did last year. You have to understand, in 2 weeks, what they did, I didn't do a lot. I just gave ideas and solutions and consulted. But what they did on the back of a, what was that? Not even a drill press. God knows what that thing was. On the back of a little cart, we built, drilled, and came up with every anchoring solution possible. Now this year, we're looking at a much more, honest to goodness, a simpler system. It really is a simpler system. This right here, this moving forward, the drive mechanism, I did the math on that. That worm here needs to be a lot bigger to be able to do the penetration and steady control. And again, most importantly, we're missing the articulated access, which allows us to then penetrate dig rather than what I was trying to coach Luke about, back up while digging to get that wedge effect. So,
I mean,
my
it seems
big-
simple, but it's very convoluted.
Yeah.
It's just too many moving parts, and that increases the complex. It makes it more complex, more points of failure, and just wear and stress on it.
let me give you some other concerns that I do have about this design. And first of all, is our ability to fabricate. And I think you touched upon that. Last year, everybody came in and gave me we got a song and dance big time about, I have this, I have that, I can do this, I can do that. That's what, please, let me talk. This year, that's why I pushed for us to go to pumping station 1. So we can take some of that away. But still, pumping station 1 gives us facilities. We need, if you're gonna do a design like this, you're gonna have to say, okay, what kind of processes are you gonna have? If you're talking to me about doing complex machining, you've lost me already, okay? I wanna see, what I wanna know is, can we do this within the range of skills that you have, that's on there? And I don't mean trying to hire some guys at pumping station 1. The skills have gotta come from your group to do that. And I want all of you guys to be comfortable with doing that. Are all the skills that are gonna come in there, are to put that in, and it's gonna be doing it in time. That's the other thing. On a design like this, when you come in there and, there's a lot that can go wrong in a brand new design. And this is what this is. I'll be very blunt. I don't look at this as a modification. This is a brand new design. This is something beyond what we asked for. I want everybody to understand, that's exactly where I stand. So that means what I have to do is, I'm gonna have to convince Oakton that this is going to fly. Okay? And to be honest with you, I have my misgivings. I have my misgivings on this, because again, the thing about it is I like the idea. The idea is good. I think the idea is good. I think the fact is, we talked to Oakton about a 2-year cycle. Now what I have to do is, I have to go explain that, I need another 2-year cycle.
Let them explain it to them.
well, here's the problem. With that 2-year cycle you're talking about, it would apply if the rules didn't change. It would be
Yeah.
consistent if the rules didn't change. But because NASA chose to change the rules,
Well, let's stop.
we cannot expect same results
Okay, let's
or
talk.
better results.
Let's talk about those. Let's talk about those rules for a second. Let's talk about results. Number 1, those results were fully expected. As a matter of fact, when they announced those rules, one of the things that I told everybody on the team is, thank God we have a robot that's able to at least meet those. Most everybody else had surface skimmers that they're going to have to do. That gives us a 1-year design edge that we have on some other teams. So some other teams are just starting about this. Number 1. Number 2 is, if you take a look at, has anybody bothered to take a look at the detailed data that NASA put out, that showed how each robot did, mass, weight, and everything else? That tells you, what you can do is you can correlate their design to how much IC regolith and BP material. It's a 32-page document, it's on their website, they tell you. You can pretty much correlate that and see what the relative success is. In 2016, we had a surface skimmer, that payloader design that we had on there. In spite of the fact it was never designed to do that, we still managed to get 1.8 kilograms on the first run of IC regolith. Why? Because a lot of that stuff, NASA tells you that it's 1 inch below, but in reality, there's some intermixing that goes on in there. So you're gonna get some. If you dig a couple of inches deep, you're gonna get some. Maybe not as much as you want, but you're gonna get some that's on there.
And basically, you're trying to go on the safe route here.
Basically what I'm telling everybody here is this, that if we're gonna go tell Oakton that we're going to go with a brand new design, we better be damn sure that A, it meets it meets all of our requirements, which means that we have it as, that we meets budget and it meets time scheduling. I'm not gonna go through a second year and say all this, and go up there and explain to somebody, how come we screwed up? We can't do that. We dealt our wild card last year. We do that again this year, I can tell you right now, they're not gonna fund NASA robotics next year. That's what's at stake, and that's what I'm telling you guys right now, that's on there.
Well, then now you guys, as a team, realize the gravity of this project, okay? So, the question is the work gonna be put in this time? See, last year, what I saw from my end was, I saw a team come together in only the last 2 weeks, because there's so much
Exactly.
drama and politics. But, what you all did in the last 2 weeks is phenomenal.
Exactly.
So now, if you can pass on that same culture that we basically cultivated in the last 2 weeks into this entire year, that design is absolutely doable. And the fact is, you get to walk all the way knowing you designed something new that is going to be successful, that was thoroughly tested, and really set this program in the right direction for the next 4 or 5 years. Or, as a team, you can play conservative, go with that platform, make some adjustments, and go in there, like I said, on some piggyback, under par success. Now, that's how you're gonna look at it. If you guys wanna build this and be credited for an incredible design, which I think is gonna be phenomenal, be the community college that took it up a notch, okay? That means every Saturday, maybe even coming early, planning, working even on a Sunday on the project.
And what this means is everybody, not just all people up there, that means everybody comes in and puts the time in. That means the electrical, that means mechanical, that means software to put this in. I mean, like I said, what we're looking at here is that one of the things that we did last year that went wrong is that we have most of the people on the team that were never at the contest. In fact, the only ones that were at the contest, there was only one person, yours truly, okay? She was at the contest, okay? Everybody else was not. So they dramatically underestimated their times, dramatically.
And I would like to say that from last year, the reason why I was so upset was no one listened to me. And I have the most amount of years of experience. I have Mohan, I have Carolina, I have Mahavish, I have Declan on my back. And that was the most frustrating part. So you gotta listen to me when I say about my experience. Now, the new team has some experience, it's still not enough with mine. So you gotta have that in the back of your mind when I talk to you.
And I think the thing is what I'm looking at here is that, do we have that? Are we gonna be able to do something like that?
We're definitely willing to put in the time and the work that needs to be.
Are you gonna put in the time and the work, given your other life commitments? That's the other thing that I'm gonna be later.
And that's another thing, because I asked people for outreach, and I hate to, sorry software team, but like, for example, I don't think we're gonna do the charter school. Even though the charter school is a great opportunity, no one has time, or anybody that put in their time would be Luke. He's the only one who responded. So we can't go back to a school and teach classes because no one has responded. And I've done this a bunch of times. So I don't think the charter school will be a go if you guys are willing to put in the time.
And that's just for outreach. I'm not talking about something like this.
Exactly, yeah.
So if that's any indicator, you have a no vote from me right now.
I don't know about the rest of you
Hold on, real
guys.
quick.
So,
Keith has something.
so coming from electrical, I
Mhm.
think this is a phenomenal design, by the way. It's a great concept.
Good, okay.
My only issue, and I'm sure a lot of us, was time exactly. Like, are you able to finish this off in another couple months? Because we have time to actually test everything in the software here, actually implement electrical system. Then it's a matter. It's not just a matter of fabricating the robot. It's a matter of integrating everything.
I agree.
And at the end of the day, if you can't integrate, then you're not going to.
You're not gonna make
it.
I don't know about the rest of you guys, but in the last month, I personally spent 50 hours in CAD and Fusion 360 designing the robot. Right now, we're actually ready to do Rabbit Pro.
And I got nothing to say that. I've spent some time.
Yeah.
doing
Yeah,
this
that's
as well.
nothing.
And I
I'm
can tell
sorry.
you right now, like, just because you can design it doesn't mean you can build it.
I don't know,
Exactly.
we do have experience from last year, we do have,
That's
you know, we can find how it's available out there, as long as we're willing to try. Now, these guys are passionate about this design, and I know a lot of people are excited about it too, you know.
That's
When you wanna work on something that, you know, excites you, that you wanna be a part of, you know, sometimes we're hashing old designs, you know, it's fine, we can improve on it definitely, but you're not gonna get as much commitment and devotion from these guys as, you know, something that
It's not just from this team, it's from the rest of the team as
Yeah,
well.
I agree.
And that's, and the thing is that I can see that we can build this, but like Peter said, it's integrating everything that's gonna be the real problem. And that's gonna be issue. For example, 2016 was a perfectly good example. We had as a base that robot that was in there, and we wanted to put autonomy on top. Everything worked out, the bits and pieces, everything worked out. We had a good robot, we had some of the sensors that's in there, we put everything together, everything went to hell. And that was in the last minute that's in there. So I wanna make sure everybody understands, it's not just this, it's the integration that goes in there. And it's gonna take the time for every one of us on the team to put in if we're gonna have something like that in there. And I agree with Peter, this is a good chance to go in there. But my history, my own experience with NASA robotic teams as Oakton has been that it is a rough going with any type of teams. I talk to people who manage other teams, including Alabama. They will tell you it's tough getting anybody to work, even in a 4-year university. Very, very tough. And you guys are talking about, yes, building a wheel, but then you've got to integrate it with the rest of them. How are we going to dump? How are we going to do all of that? All of that has got to come into play. That's on there.
I have a question. So in the calendar, where do you think the electrical and software team can start testing? So what are they gonna do fall semester? Cause last year they were just twiddling their thumbs until mechanical team was finished.
this timeline doesn't change for the redesign of this.
Okay,
It's,
But
like I said,
like
it has to be built.
where's electrical and where's software in between this timeline? In between your
Well, last year,
milestones?
You know, they're designing the electrical box right now.
Okay,
They can build it separately and integrate it during, the frame's gonna be complete beginning of January. can start-
where's the electrical box being placed? Can you go back to your,
You have two spots, either behind the wheel or on the side of it.
okay,
Actually, no, it's gonna be right next to the hopper. I actually already put it into the CAD design.
And how big is it?
Okay, so the way I have it set up right now is that, like, it's gonna be basically the whole entire back of the box. We're gonna have like 2 compartments, the hopper for the gravel and then the electrical box.
have you talked to this with any of the electrical team about their opinion?
Well, this is just the concept study. We can-
This was
Yeah, but you
done
talked to
last-
Luke about it
This
though.
was done 2 days ago, so.
I think what
This
you
is
guys
just
should do-
concept
done
studies,
2 days
so we have time for design.
I talked with Jason yesterday about getting, working on mechanical box, or electrical box dimensions. I tried relaying that to Simon, and I asked, Jason if they could get a more firm,
Because we
grasp
don't know
over
the dimensions
dimensions.
of the box that we're working with in design, we don't know the dimensions of that. We still have to figure out the motherboard stuff, if we're gonna put that into electrical box, or can I just get smaller? So,
I'll tell you what, originally, I was going to make a decision, approve this year, this week. I'll give you guys another week, but here's what I want. I want you to talk to the other team and get an idea of what's going on here. It's on there. As far as I'm concerned, it's a great idea. But how much are we gonna have? Yes, sir.
So I wanted to say, first of all, thank you so much for the alternative concept studies. I can see that we're really zoomed in right here on this bucket wheel excavator. I'm pretty confident on the idea because I saw it work for Alabama. That's what they have, and I think it's not a bad idea.
Well,
Yeah,
theirs
well,
is a little different, but what I.
Sorry. The bucket design. The point is that I want to make sure that if you guys are really keen on doing something much harder than we anticipated at the beginning of the year, that you're also ready to meet with earlier deadlines than we originally started. So if you guys can finish up, like right now we need you to finish up the CAD before you start fabricating. How much sooner are you going to turn in the finished CAD files? I'm talking with sensors for autonomy. Like how soon could you turn that in? I mean, I don't want to say no, that we are not going to do it, but if you just followed up your enthusiasm with work to show it, I think we'd have a lot more confidence going forward.
I think,
Also, how many files do you guys report to the Fusion V60?
I have everything shared with the mechanical team. I could share it with everyone else today.
The reason why we have a shared folder is that we can.
Yeah,
Yeah, I see Peter share it all the time, so.
So I know
You guys got
Yeah.
application
the reason why we went with this kind of like concept or like structure was so that everyone had a visual of what was going on. I just like to keep the entire.
Yeah, okay, I'll share it today.
what do we want? And I'll tell you what we're gonna do. Originally, I was going to, when this is make a decision now, today. I'm not gonna make that decision. What I want you guys to do is, I want you guys to address the concerns that I have, mainly commitment. Are you gonna get commitment from your teammates? And I'm gonna ask that to everybody, and to all of you individually, to do something like this. And I want also, particularly the electrical team, to go in there blind. We're not gonna have it like last year, where it took several weeks for people to find out where to put sensors in. I wanna have some answers starting next week. Time is running short, okay? Time is running very short on something like this. And to be very honest with you right now, is unless we get some answered within a week, we're gonna be going with that design regardless of whether we all like it or not. I'm making that very clear. That's on there, because that's right there, it's sitting in front of us. We know what we have to do with that thing. Shortcomings and all, that's on there. So we don't have a lot of time. Next week, let's see some answers. And I want you guys to meet with Peter, I want you to meet with the electrical team, so you see where everything goes. I want you to also meet with the software team. Where are we gonna put the sensors? Because integration is key on a robot like this. And this is a radical design. And I'm not going to make any decision at all until I have a certain level of confidence that this team is gonna do something like this. Because to be quite honest with you right now, I'm a very, very deep skeptic because of past things. Because even when we built, if you take a look at our success that we had in 2016, that was a result of 3 or 4 years of hard work that teams have done. And again, the problem was always we were battling the same thing every time. Time, allocation of time. Some people had different academic loads that they had in them. And that was the biggest issue that we had on there. This is going to take that same, and we were talking about a simple design. You take a look at that, this is more complex. How are we gonna do that? Given the time scale that we've got, yeah, it seems months away, but it's not.
You should also talk to Jeremy and Sean about scheduling.
Yep,
And
that's
also
right.
for the record, Jeremy has been asking for these CAD files. I know you have your workloads and stuff, but he has been asking for it.
But yeah, but that's my bottom line, it's time. How are we going to, as a team, then everybody's gotta buy into it. I can't have 3 or 4 people working their tails off and everybody else sitting there doing one of these. Or saying that I can't do it because I have too many courses. Either we're all in it or we're not in it. And I'm gonna be asking that same question to each and every person that's on there. I know some people here, they go to UIC, and they're only able to be here on the weekend. So how are they gonna be able to contribute to this with a full course load that we have? It's not like we are a company where we have full-time engineers. You talk about the mining companies, yeah, they have several hundred people in their engineering department that test the stuff. We're not. So we have to look at our constraints. And that's where my problem comes in, is constraints that's on there. If I'm gonna sell this to Oakton, then we better make damn sure that we have the commitment from each and every what's on the team to build it. Otherwise, we're gonna be working on that.
So
That's all I have to say.
let's be clear, fair, and realistic. If you guys, I'm not saying a complete draft, but next week do another presentation with the robot that what it's going to look like. So more detail on this, like with the sensors, the electrical box, all that stuff. If you can really work on that in a good presentation next week, I think we'd have a lot more confidence as with the whole group moving forward. And that's going to be
I
a
want to point out something, and something you guys all need to understand. You got to give a lot of respect to these four. You know why? Because while you guys build systems for what is going to be added in, they have to build something from scratch. They have to think out of their heads what is the best way to do it. They got to get creative. They got to apply themselves. They got to draw off of experience and observations of existing systems and nature in itself. So while it is easy for a lot of you to ask these things, we're going to ask the same from you.
Exactly.
They'll fall short on the electrical. Pull on the same ingenuity that we did. Okay? Most important, the teamwork. See, the one thing that brought this team together last minute was that. Okay, and I know we were working from behind, but what failed was the fact last year that the engineering team and the mechanical team didn't have the leadership, right? Rested everything and all their, eggs in one basket kind of situation. This year, I don't see that. I don't see this, dominant. I see a very good collective that communicates, but that means the rest of you too have to do that.
And that's what I want. I think what Peter says is exactly what we have to all have that together. Unless we see the teamwork, unless I see the teamwork or something, we're not gonna succeed.
And I should ask you guys for help us out this week. So if we come to you with questions about where do you want the sensor, where do you want this, tell us so we can work that in and make the design better than it is. Because we really want to do this design and we're really passionate about it, and we want you to get passionate about it too. So if you put the work in with us and collaborate, you're gonna get passionate about this design too. Because we really think that this is the best way to go, and we can get up there into the rankings if we make this design really work.
we're going to be good friends this week.
Yeah, that's.
We're going to be good friends this week.
And the thing is, like I said, that's what we want. I wanna say, I think the fact is that last year, what we've seen in the last couple of weeks, I've seen a couple of people get together and really pull all the stops out. And in a way, that was great, we've seen that. But the fact is, we have some other people that were standing there twiddling their thumbs. What we wanna do, if we're gonna make that design happen, we gotta all stop twiddling our thumbs, okay?
And that also means that electrical, I completely agree with it. Electrical, start seeing where you've got to put stuff.
Yeah.
Take the initiative. We don't have to spell it out to you. I understand what you're asking for, but guess what? There's a lot that you could, or anybody else in other departments can say, hey, listen, these are some of our inputs, and it can start integrating. See, all I see here right now is 4 people getting shot at. And it's really easy to be skeptical. I worked in an industry where I had 4 plant managers that manufacture the F-450s sit there and just keep doubting and doubting. It's easy to do that. There's so many people who do it. You know what you can't do it? The innovators, the intellectuals, those that think outside of the box and are flexible. But most importantly, that can function as a team and communicate. Otherwise, I can sit here and doubt. Sanjita doesn't know what she's doing. How do you know you're going to put all those motors the right way? Are you sure there's going to be enough amperage and torque? I can do the same thing with you. Google let have all these codes. Who are you stealing all this from? Do you know what you're doing? But if we start seeing software saying, I've been researching, been doing labs, this is what I've come for. I know how I'm going to get that wheel to start spinning. Well, you're already covering a base. Now, Peter behind me here starts figuring out, I know where I'm going to run the wires. I know how the wires and all the equipment is going to come down to keep powering the wheel. I can see that. All of a sudden, it's a collective. People are already solving problems and staying ahead of the curve.
Exactly.
But I understand.
There's one thing though, so this is a huge, step back from last year. You can't integrate electrical systems when you don't have a finalized design. If you keep changing things, you don't know where to place it.
Well, and that's the thing what we wanna do. I think that's great. What we wanna do is we wanna come up with some kind of design that's in there and say, okay, we can do that. I agree, between the time you come up with a preliminary and you come up with a final, there are gonna be some design changes. We have to be flexible in that regards.
It's true.
And that we have to be, I mean, there has to be some flexibility, because by the time we get through putting this thing together, or putting the final design, there are gonna be some things that are gonna come flat out and hit us in the face. That's not gonna be there. But what I wanna do, and I wanna do from right now, if we're gonna go with this design, and we don't have a lot of time, is we need all the teams to talk together, and we need everybody to pull in what they need to do. What do they need? What do they want? What are some of the dimensions? What do we need as far as running wires goes? Last year, for example, Peter didn't know anything about electrical boxes. Now he's got to be a real good expert, especially for seeing that. So I want us to be able to see where we're gonna put those. Where we're gonna put the sensors. What kind of sensors are we gonna need? That's gonna be that's gonna be it's gonna be a challenge. So our thing for next week is going to be, let's get input from other teams, and let's see how this is gonna work. It's on there.
We have a basic design that we have come up with that we haven't shared with you guys, so we're gonna do it today. So, I'm just telling him to pull that up right now.
Good, let's take a look.
What I see is every email that Peter sends out, so Adrian, if you could figure that out, then
Yeah.
I would
Yeah.
appreciate that, yeah.
Another thing, you have to understand, I believe in these guys, I get nothing out of this. Zilch, no, credit, no, I don't care. I'm here because I see 4 terrific people that have great ideas. And I wanna see the rest, well, I'm sorry.
No,
I've been working with them so closely, I'm sorry.
Okay.
But I do see the rest of the team have that same potential, and I want all of you to get, well, yeah, even the legacy team, Sanjita, Peter, the rest of you guys, you know, those knuckleheads.
Well, I think, let's put it to you this way, like I said, this is, I'm looking at this, and I'll give you my opinion, that's on, great design. Can we pull it off?
Yeah, so we're gonna put the gantry system here with the one motor running there with the U-shaped thing. We're gonna have the hopper here, and we can adjust the size to fit the electrical box where we want it. So we can have that. We're gonna have
The electrical box is gonna be here, so if we need to, we can shrink this.
Yeah.
Also, this conveyor belt is actually gonna be attached to the axle of the motor, so that we're only gonna have 2 motors running the whole entire digging mechanism. The one motor is spinning the wheel and the conveyor belt system, and another wheel or a motor spinning the gantry.
Well, like I said, I also wanna take a look at, when you guys are working on this, kind of flesh out a little more what the gantry looks like.
Yeah,
It's kind of floating in there
Yeah,
someplace.
they run it, they didn't have enough time, but yeah, I like what you're doing already, you guys already thought ahead of it.
Yeah, and I think the frame, let's take a look, let's flesh out a little bit of what that frame looks like, because I'm looking at the frame, I'm looking at, flexing and everything else, I realize it's a concept more than anything else.
Yeah, the wheels are gonna
the
move.
frame we haven't come up with, but the main system that we're worried about with the wheel and the hopper, where the electric box will be. So we're gonna work on the frame more after this.
Okay.
The design is promising.
Yeah, it is, like I said, it is promising. My question is, can we go from there to where we want to in the time that we need to be? And that's the case. So, let's do this. You guys talk with the rest of the teams. So let's put some kind of an integrated plan together. Next week, let's do an update.
How long can they stay in this, building, on set?
6.
So,
You guys might wanna start opening your windows up to 6.
Yeah, 6.
it
And
could be-
For everybody.
again, I don't want, what I wanna make very clear, I don't want just these guys to be putting in their time and the sweat. For this to work, all of us have got to put in the time and the sweat, all of, every single last one of us that's on it. And if that doesn't happen, then we're gonna be working with that, okay? That's the choice that we face, and that's in there, because, and that's what we were looking at. Yeah.
Can I, it seems, because this is what I've seen so far, and I've seen this happens with the software team. Everyone has very different schedules, everyone has limited amounts of time, and then there's, between the teams, there's sometimes lack of communication because mechanical teams having their meeting, same time the software teams having their meeting. So I want, this is more directed towards Angel, is there a chance we can have a set hours that, instead of, we come here every Saturday, people usually start coming in at around 11, they start leaving around 6. Is there a way we can have the rooms here open on Friday and Sunday at similar hours so that we can come in the whole weekend and do more work?
First of all, Let me answer that question for you, because I think I'm in a position where I can answer it. First of all is, I'm here on Saturdays until 3:00. So I'm not said about on Fridays until 3. I have a morning class, and if you guys wanna come in here and work, you're more than welcome to do that. So I'm here till 3. Jason comes in until, what time do you leave?
4:30 to 6:30. I can stay
4:30.
longer.
Yeah, 4:30 to 6:30. Okay, he's here until that time, and you can also do it as well. Saturday, I'm usually here at 11. I usually maybe 1 or 2 people. If anybody else wants to come in at 11:00 or 10:30 or whatever, I can certainly do that. That's on it. We can have this open, and usually everybody can tell you I'm here until 6:00. I'm here till 6:00 when you throw us out. As far as other times goes, where you can come in, Tuesday and Thursday, I'm here from 3:00, and I usually have a class in this room or downstairs. But you're more than welcome to use either this room or the other room for classes, for meetings, for whatever that you want to use. Those rooms are unoccupied. So I'm telling this to the entire team. If any of you want to have that particular information and that particular support, I can make that room. I can make the supplies available to you. Certainly, when Jason's here, he can do that as well too. It is open. What is missing, however, is how much time can you put in? That's on there. That's in there. Now, again, we can make adjustments, but that's starting point of what we can do.
I'm also setting up a doodle for a weekly schedule, so it's just like the week of next October, under the assumption that, your following weeks are the same, so you don't have to repeat yourself. Of course, like, things come up, like, for example, my senior design partner, his grandpa's in the hospital, so things like that.
Yeah.
We understand.
So again, we're dealing with a wide variety of schedules, a wide variety of commitments that were made by this whole team. So hopefully, I'm giving everybody, let's talk about this again. Everybody take stock in what your situation is, and we'll see what we can do. Let's talk about this next week. In the meantime, what I want to do is let's keep evolving with that design. Electrical, I think we've got some work to do right after this meeting. Okay? All right. Any other questions for these guys? Alright.
Yeah, you guys did. I know you guys had a hard week, so
Yeah.
yeah.
I know it felt like Shark Tank for a while.
Yeah.
That's fine. But anyway, very good. Let's give these guys a hand, okay? Anybody who can stand up to my withering questions deserves a hand, okay? All right. What's next, Lynette?
I think Jeremy, because you want to go from the critical path analysis, right? Do you want to talk about that?
So I just shared it. I talked a lot with Luke in the morning about it to fix it up, but I guess we could just kind of briefly, if I could just get 1 or 2 people from each team to just eyeball it and say if I'm missing anything serious or not. Where is it at?
Check your email.
Yeah, I also posted it on Discord. Everyone should have access to it, and I've also just got it on my laptop if you just want to physically walk over and look at it. So,
Oh, that's the thing I always saw.
yeah, that's what
I'm just gonna be here to keep you company.
Okay, thank
Because I
you.
already moved, I feel stupid moving back.
I need as much emotional support as I can get.
I know. I know Sean isn't here to give you that emotional support this week, so I'm here to make up for it.
There we go.
I have a saying. You got it, man.
Thank you so much, you guys. I try. So I've identified the critical path as in a thick black line. So anything that comes in late in the thicker black line pushes everything else back. And so everything beyond that will have less time because we do have fixed deadlines at the end, but we have softer ones in the beginning. So today I wanted to formally conclude our mission concept review, which ended our alternative concept were reviewed and talked about and such. So I know we didn't get CAD files of each design. We do need that to formally pass it, but as long as we know as a team that we adequately address the pros and cons of each decision and that we did make the right one based on that, as long as that is documented well, I'm not going to be a stickler on you guys. I don't want to get in your way. You guys have a lot to do, and so, I really respect a lot of the work you guys are doing.
Yeah.
That's pretty much it. A lot of the things we've already started into our systems requirement review. Let me just eyeball that really quick. So verification and validation plans, our system hierarchy diagram, our data flow diagram. I know Luke and I are going to work on that. Data minimization. I really want to talk about that, and I cannot stop talking about that, you guys. Had we gotten a qualified amount of regolith, we would have won a trophy. Our manual operations used less data than Alabama's autonomous operations. Okay? That's a section they would have wanted to read about, except we turned in our systems paper in April, and that actually happened much closer to the deadline, so it didn't really have the opportunity to, but it is going to be included and well documented in this year's paper.
Luke had a late flash of genius, right?
Yeah, just last second change.
Alright.
Fix everything.
Okay, good.
Very loosely, we'll talk about risk assessment and mitigation plans. So identifying all of our risks, as we know, we have our reset system to turn it on and off again, and we also have, if autonomy fails, to switch to manual mode. But there isn't any more troubleshooting we can do. You know, if it dies out in the pit, it's just over. And so we need to focus all of our attention on prevention in the first place. So, you know, we were talking a little bit, I talked with Jason about things like spring-loaded standoffs. I talked about conformal coating. You know, it's just like a laminate. Yeah, we could put on maybe the edges of the stuff. Just really focusing on dust-free operation. You know, a little bit of dust into the electrical system that can make things not work. Very sensitive chips and wires and such. You know, we'll talk about this more in detail in the next coming weeks, but I want to say that we've done an incredible amount of work thus far, and I feel much more confident right now on October 7th of 2017 than I felt on October 7th, 2016.
Yeah.
So, good work, guys. Keep it up. Keep the energy up.
Sorry, could you explain what the MDR, FDR concept is?
Yeah, sure thing. So, what we did last year is we defined a lot of the systems engineering process, the phases, and what we needed out of them. This year, what we're doing is we actually focused more on the reviews. The reviews are at the end of each phase a checklist. So let me just run through. There are two sections here. The first, in our success criteria, is these sections shall be considered drafted with peer feedback. So the abstract, the purpose statement, the design philosophy, the requirements table, the systems engineering management plan, concept of operations, trade studies, and alternative concepts. At the very end, what I did is I've also annotated these things, so rather than just saying, yeah, we did it, what I'm trying to put in the systems paper is to say, the abstract was moved into from pre-phase A section for spacing issues. You know, we put it behind the table of contents so that it was not formally in the paper but still included. Just little blurbs like that to show that we're actually doing these reviews section by section rather than just a checklist and say, yeah, we did it, and then, you know, it moved on or something. Because last year, if you read our systems paper, it looked like everything just went by flawlessly with no problems, and we have no idea why anything went wrong.
Incredible.
Like, so.
Incredible.
It was just like a progression.
Yeah, it's a checklist. So the important things here is that I've also dated. There's also managerial tasks considered complete. So success criteria for all the reviews need to be drafted. Technical teams have been informed of their expectations, due dates, communication interfaces have been established, management software, inventory list, thank you, Simon, system hierarchy drafted, software development schedules drafted, safety critical software drafted, and software validation and verification. So we just checked with all these things to make sure that if we're going to say that we're formally done with pre-phase A, that we can successfully and with confidence know that what we're doing is at the right time in the right order, instead of having someone, you know, kind of shoot far alone, lone wolf, and then realize, oh, well, you missed all these dependencies, so all your work is for nothing. You know, like, we want to avoid that as best as possible. Yeah, Ben?
Yeah, so I didn't think about this before when we were looking at it, but now after the mechanical team presentation, I'm realizing that we need to connect the mechanical team CAD files, with the electrical box CAD files, with our decision, the software team's decision on what sensors we have, like that all has to be checked before anything goes into fabrication.
That is the beauty of a critical path analysis. Yeah, so if you guys,
So we have to move this around just a little bit, but it's all pretty much already there.
Yeah. Well, I think the other thing too, as a result of me cleaning up the wiring mess that we had in that robot, we discovered there's a lot of components I can pull that out of it. Peter noticed, the first thing that Peter did was he noticed when you looked at it the other day, hey, the thing looks a lot cleaner, because I removed a lot. So what's that gonna mean is, our job with the electrical academy is gonna have fewer components, it's gonna be much more reliable. It's gonna be on there, so it's gonna be much more reliable. So from that aspect, Peter doesn't have to worry about how much stuff he has to put in there.
Yeah, only you cut down a lot. So.
Yeah, I mean, I really went through, I chopped like crazy, I went to the mad chopping block, and by the way, it works, okay, it still works. So the one thing we wanna do is, as again, is we make sure we have in there, hopefully we don't have to do any soldering or PCB design, except one thing that we want to do, I'm gonna ask that everybody in electrical team does, please let's minimize crimp connectors. Wow.
Yeah, it's a big deal.
Yeah.
When I pulled out the wiring out of that, I couldn't believe there was one wire that had 4 crimp connectors on them.
I mean, we had like a week to.
Yeah.
Just throw it
Wow.
on the
Wow, anyway, all right, good job, thank you.
Thank you. Thanks
All
so
right.
much.
Anything else in that?
We'll review the Gantt chart with Sean. So, yeah. Unless you wanna do it, Jeremy. We're still thinking of a design, so I don't think that's really necessary right now, unless someone wants to talk about what they're doing. Okay, here's the boring part. Sorry guys, I'm doing outreach. Oh, the cool thing is, I talked to Matt. Where's Matt?
Where's Matt?
So, we're launching all our logos on October 10th. I don't know if you can read that, but he gave me a
Control
link
plus.
on how to launch the website. Jeremy, I'll talk to you and Lizzie after this.
Thank
So we're going to launch with our new logo and stuff on the 10th. Timing is everything for social media. I was actually talking to a CEO. She's like the youngest CEO in her company, and she started doing better with packaging and also started social media before it got even popular. And now she owns a $123 million company. Isn't that cool? All right. So, Boy Scouts. Can you guys read that, or should I make it bigger?
If you can make it a little bigger.
Okay.
Thank
Give
you.
me one. Is that good?
Dylan.
One more.
One more. There we go.
Okay, so Boy Scouts. I've talked to Luke about it. We do have a hand that we're going to make, so it's going to be a robotic hand for these third graders, and we're going to send in the prototype to Kate Morin. So the good thing about Boy Scouts is we can always like host different dens, and we can do the same design. We did a hand design last year. It was pretty cool. And I asked for donations instead of charging them $5 or $10. I'm like, well, why don't you just send us money, or like, go to this website instead of us charging you $5 or $10 per head, because we looked at the costs and most of them were reusable, and I thought it was really trivial to like cut it down. So yeah, wheelchair project. I talked about this before. It looks like we have a team of me, Luke, Sanjita, Alex, and Peter Radikovic. Does anybody else want to join the team?
Can you explain?
So it is, yes, I will explain it. Let me, I wish I had like a recorder so I can not repeat myself. So it's okay, I'm just joking. So go to outreach. And I also posted a video about me talking about outreach. I know it's very exciting. Go to wheelchair. And long story short, this was a senior design project that I picked up by my professor. And he's been prodding me for where's your sketch, where's your design? Can the parents talk to you? Like, are you the leader of this design? Yes, we don't have a sketch yet, so I do want the people who are interested in the wheelchair project to talk to me, I will reach you. So basically, if you read through here it is. So if you read through the proposal, we're helping a boy who is bound to a wheelchair for life, have him lift up and transfer to his bed without using his hands, because he can't really have good motor control with his hands. It actually says right here. So this patient is unable to use his hands very effectively, therefore he is looking at a way that the transfer board would come out automatically to let him transfer onto the bed. So it's something similar to what Alabama did. Alabama made a boy with he had deformed hands. They helped him drive a toy car. But I think this is more permanent for his everyday life, and definitely like something that is great. I did talk to my senior design professors. They gave us two advices. One of them, the company is not that good because the customer will always want something more, and these are parents. We're talking about his parents, and his parents are obviously protective over him. So they're not going to be satisfied with our design no matter what. It's like what the customer wants and what we can give using our engineering skills. So please be aware of that. Also, another thing is to not take it personally. You need to think about this objectively. So not just a boy that who was bound into a wheelchair, like this is a sad story, blah blah blah. You need to think about this objectively and hopefully use your engineering skills to use to solve his problem. And he lives in Villa Park. I looked it up on Google Maps. It's 30 minutes away. I would like to visit him, and I would like to see what the old senior design group did with their jack. And this is not good depiction, but where is it? So this is their design right now. I want to see how he uses it. So it looks pretty bulky. It wasn't that successful from what I hear. But the good thing is we can use the tools that they gave us. So there's two things that comes out of it. We get the linear actuators, we get the Arduinos, we get the tools that we need from UIC for free. And that's good. Another thing is if UIC is the number one in research, and they're number one in research universities, for those who go to UIC, you didn't know that. Another thing is if we are successful in this project, UIC will donate money to us. So this is why I think it's an important outreach, not because well obviously it helps like a disabled kid, but this is basically given to us. I think we just need to spend a little time on it, and I don't think it'll be about 80 hours of time estimated. So if you're interested in the wheelchair design, please talk to me. And like I said in the video, it's not my wheelchair. It's actually a completely different wheelchair like this. So we're looking at a different system, and we don't have like a wheelchair to like base off from besides mine. So I did talk about that in the video. It's on Discord. You can watch that again. So who's interested in the wheelchair design?
I'm interested.
Sorry, I don't know your name.
Age.
Age, sorry. Who else said Peter? Oh yeah, Peter R. I love Peter. So sorry, you look different today. Alright, this is the one I'm kind of salty with. It's the charter school, and we've talked about this every year. Let's get a charter school. Let's get a CPS school. We ended up getting a charter school because I talked to Luke. Luke's mom is she works in CPS schools, and they don't want to put in money for STEM. So this is why we went to a charter school. Long story short, this guy came into PS1 the first night that I came in, and he talked about someone in software that can teach a high school class something to code. And I put this on Discord and I emailed y'all, and I didn't get any response besides Luke. I think reason being is you don't have a resume ready, because I sent my resume to the principal, and I have not yet sent Luke's resume to the principal in accordance that people will be more interested in this. So you would probably meet on Friday. You could probably do this like 2 or 3 times. You can establish a class, and I think it's really good because it seems like their STEM program isn't that great. When I checked their website, and it's not too far from PS1. Yeah,
So it's probably somewhere documented somewhere, but so we're on Fridays, is it like a set day of the week?
well, that's what we're gonna talk about next if they accept us. They
Okay.
could probably, I don't know. He said that he was looking for a permanent position, but I told him we're a robotics team. So they're not probably gonna donate, but it should be a win-win for us and them, because they don't have to pay us, and then we can get an outreach from them. So they'd probably be more aware of that. What?
If it's on Fridays, I can help,
Yeah.
so I get
Yeah,
involved.
I can also participate if,
Oh,
on a Friday, like I said, after, like I said, 2, 3 o'clock or something like that.
Yeah,
I can-
okay. So they never had a set team.
Mhm.
No, I can't do Fridays. As for the curriculum, for the lesson plan, that's totally up to you. What I did for kids when I taught third graders, I made them, I helped them set up a Raspberry Pi computer, and then we did Python, and then we made like cool codes in Python and Minecraft. So this is a high school class, so maybe we can do something like situational, something that they can take. So it's basically whatever you want to teach, what you're comfortable in teaching, and I just need your resume so they can, take into account like what you know. And that's what they're asking. Yeah, Alex.
So yeah, I was asking about Friday because I can't do Fridays.
You can't do well Fridays is so they just said second or third quarter, so I don't know if it's like Friday or Thursday, but
Okay.
I can definitely
Yeah, just inform me on that because I love teaching computer science, but I just can't do Fridays. Because I work.
okay, what days can you do?
Let's see, Monday, Wednesday, Thursday after 2 o'clock.
Okay, so I'll look through Doodle and then I can say what their availability for each
Okay.
member is.
And what we can do too.
Yeah. Okay.
And what we can do too as well with that is that I can also, if you need materials, we can get some materials that we can use as well for that too, okay? Arduinos, lesson plans, projects,
Yeah.
whatever.
Yeah, you can probably help them like why don't we do the 10? What?
Is this like during their school hours
It
or
probably maybe. That's why I was like saying like Friday, because usually students don't have Fridays during their classes. That's a big assumption. That or after school. We never agreed on a time. So I could probably like ease in and probably go into our schedule rather than theirs. It could be like a club, but from what I was told, it was more like a class. So it is probably during their class time.
I'll send you a resume tomorrow, but I do want to put out there, if it's on Friday, then I won't be able to make it. So
That's fine. I can like negotiate times, like I said.
Yeah.
So I'll email you guys after this meeting. Reminder to send in your resume. I can look over your resume and then tell me what days are available and I can talk to them about it. So this will be in the second and third quarter. I haven't looked in their academic calendar yet to figure out what days they are. But I am leaving like one person hanging for like 2 weeks. So this is the thing about outreach when you're communicating with people. So you don't want to leave people. You don't want to leave people like hung up in the air. So that's why. Yeah. So.
Also,
Yeah.
I'd like to say that I am working with my mom to get a couple class demonstrations at Steinmetz.
Okay.
So this is a CPS school. It would be during school hours, and the goal would be to do a STEM-based presentation as well as robotic demonstration that has something to do with the class. So if it's in like a chemistry class, we would do a STEM-based chemistry activity as well as discuss how that relates to our robot. So like for chemistry, we would do why do we want to dig? Well, we're looking for water. And why is water so important? Because it's fuel and it's necessary for plants and it's amazing. And I like water, you like water. Water's great. So that kind of thing. We would want a class demonstration that is related to the subject that we're demoing to.
That's really cool.
So I can work with whoever wants to do this. There's no firm dates. It's still up to the principal as to whether or not he'll allow an outside school during school hours. An outside team type thing to come in during school hours and talk to the students. But if we get approval there are 3 or 4 classes that I know are interested, and so we can start to work on lesson plans or something.
Yeah, definitely.
Collecting like order and stuff like that.
Yeah. So this sheet, like I said in my video, it's shared with everyone. So it looked like Adrian put in his mayonnaise robotics team. I'll let you talk more about it once you have more details. So no rush with that. We posted. Okay, I'll talk about Malloy real quick. So Malloy was super successful. For the people, 'cause I know we have a 1U outreach member. It's Lou's sister. I forgot your name.
Deborah,
Sorry, what was your name?
Deborah.
Call her
Oh
Deb.
yeah,
Oh,
great.
yeah, that's
Yeah, so we're trying to expand our outreach and social media team because if you haven't been, I know some people aren't as active on Facebook, but NASA RMC just shared New York University them doing the first robotics outreach team. They love this. They eat this up. So that's why I love our new outreach team, our social media team, because it's a lot of work, even though not a lot of engineers think about it. When you think about marketing your products, especially if you own a company, then it gets kind of important. So, Beloy, I actually messaged Rebecca McClaney because I found that and I CC'd the outreach team separately, so I'll add you to the CC. So hopefully we can get back on it with the disability school. So we had a really big success making solar paneled cars, and it was really awesome. And then I think Diana talked about like those it's like a chemistry kind of car, hydrogen.
Yeah, they have like hydrogen cars. And,
Yeah.
Angelo has the hydrogen cars.
Yeah.
But we need deionized water for that.
Oh, I got plenty.
Yeah.
Yeah.
So you get that from the chem lab.
So like any activity like sharing your knowledge is really cool. Someone said this to me like when I was a tutor. It's kind of like earn, learn, and return. So you earn like you earn like the privilege to go to school. You learn basic engineering, what you were pursuing, and you return to the community. So that's how I see it. So you want to return like your skills and hopefully make kids like engineering or STEM or more of the sciences. So who put this in?
I did.
Who? Okay, cool. Yeah, you want to talk about that?
Yeah, so a couple of years ago, over at Des Plaines campus, during the summer, they had this robotics course they taught. I don't know if Angela, you know about it, the robots course. Basically, what it is just a small robot. What we did at the end of it was presented at an engineering expo, and it was just to like gain, similar to what we're doing right now, like teach kids about STEM and stuff like that. So what we decided to do was we built a small little robot, we put IR sensors on it, and we took wooden blocks and we made a maze. And then what we did was, as students came, we allowed them to rearrange that maze, and we would let the robot go and see how it handled that maze. So that could be some sort of outreach event we do, where like we let them rearrange the maze with the wooden blocks, and then it'll be more interactive.
And we got plenty of little prototype.
Yeah, exactly. And it's not that hard to like program.
No, it's not.
To build, so.
I really like that idea because being hands-on
Yeah.
didn't require a lot from the audience, but it is very explicitly interacted with. That's nice. That's a really good idea.
So these are the things that NASA likes to throw at us. So usually they have like a stream and we pass this stream. So basically they have like what's it called? Engineers, systems engineer, financial analysis branch, so accountants, so people that will talk and they stream this and then they do this like once in a while and you get points based off how many schools reached out to watch this stream. It's extremely hard for the teacher to get out of their their lesson plan and be like, hey, let's watch about this, and then we get points. So that's another way we earn outreach points. We haven't been really successful for that in the past few years, but yeah, that's pretty much it for outreach. So I would like more people to obviously be more dedicated to outreach because it's something that you feel good about the community. There might be another event for girls that NASA will teach, another stream. So it's good to like reach out to your teachers, your science teachers, like from high school or from middle school, and then be like, hey, NASA's doing this. Like, why don't you? If this correlates to your lesson plan, like, why don't you watch the stream? So again, like, even though I have this every year too, a lot of engineering students are like, why am I worried about social media? Why am I worried about outreach? Why am I worried about systems engineering paper? And then they go to NASA and they're like, oh, now I understand. So I just want to make this clear that it is important. Like, don't put it in the back of your mind like it is like a volunteer thing. And we do make statistics of how many students are there, and I am keeping track of how many students or who is there. So we have, I'll show you. This is what Mahavish made. She actually wrote the systems engineering paper a while ago. I'll drive. So this is how I keep track of y'all. So this is the event name, and this is basically a statistics paper. So we can put this in our outreach report that Jeremy and basically the outreach team is working. So I know who has been participating and who isn't. So they're not out of my eyesight yet. But yeah, take a look, think what you can do, think what outreach stuff you can put in. It's also quality over quantity. I don't want to go too much over my time, but it is quality over quantity, and it's a finite amount of pages we write in our outreach paper. So we can't do like 15 and then be like, oh, is this what we did? These are our stats. It's not going to fit in. And one thing that I did do this year that changed was a survey. So let's say Wilmette, they weren't happy about the paper airplanes. I kind of thought that up last minute, but they wanted something more robotics. And I'm like, well, you don't have the resources to buy like all these many robots for your kids to assemble, and you have a better like STEM program than Oakton. So you got to think out of the box of how much costs and how much time does it take for our team to do. So yeah, that's pretty much it.
All right, let me, few things. Number one, yeah, everybody please think about outreach, it's on there. One thing that we're gonna do too is I wanna make sure that, if you have anything to contribute to social media, see Diana back there? And that, and, what happened to Lizzie?
She should be here any minute.
Oh,
She
okay.
gets out at 2:15 from Just Plains.
Oh, okay, displays traffic, okay.
Yeah.
So anyway, so we want to do if anything, you got interesting ideas, you got activities you do, please contact the outreach team that's on there. Deb, you're gonna get very involved very quickly and all that. So we're gonna be doing that. The thing that we don't wanna do next, I'm gonna proceed next, is about 3:00, that we have in there. We're gonna adjourn the meeting. And there's a lot for everybody to do. We're gonna be taking the robot out for a spin. Hopefully it's not raining. That's on there. Hopefully it doesn't look like it's cloudy, but at least it's not raining. So what we're gonna do is we're gonna take the robot out to the Early Childhood Development Center. What we'll do is we got the robot back in there. We'll get it prepped. Luke's got his, we got the battle box, right?
Yes.
We got it in there. We'll get it prepped and we'll head out there. What we're all gonna do is we're gonna leave from P-251, we're gonna take it down by security in the other end of the building. And what we're gonna do is we're gonna go through the gate into the Early Childhood Development Center and take it from there. All right, so anyway, do I have a motion to adjourn?
So moved.
Wow, okay, who seconds the
Second.
motion? Okay, that takes action. Okay, all those in favor say aye.
Aye.
Motion, meeting adjourned.